Hey guys. Alright, so 12.3 is about factoring some simple trinomials where your leading coefficient is 1. So here, what does that mean? Alright, well, yesterday, 12.2, we learned double distributing, which means that I start with the first term. X times x is x squared. Then I distribute the x to the minus 2, so minus 2x. Then I distribute the 5, plus 5x minus 10. Now in the middle you have like terms to combine. A minus 2x and a plus 5x makes a positive 3x. Bring down your minus 10, bring down your x squared. What I want to do today is show you how to start with, hold on a second. Start with the quadratic and work backwards to find the factors. Okay, so what you're paying attention to are things like signs. Like if this, how did I make a minus 10? Well, I had a minus 10 because I had a plus 5 and a minus 2. So if you see a minus at the end, that probably means something. Okay, and filling in the numbers. Well, I need numbers that make a 10 at the end. So 1 times 10 or 2 times 5. Well, how would you pick 1 times 10 or 2 times 5? 1 times 10 or 2 times 5? Well, the 2 times 5 subtracts to a 3. Okay? Okay, so let's do some examples of all the possibilities. Okay, so whenever you're trying to factor a simple trinomial, you're going to start by looking at the sign of the C term. And when it's plus, the only way I can get a plus there is if both the signs in the parentheses are the same. Now I don't yet know, although I can show you how to find it in a second. Are they both pluses or are they both minuses? Okay, so this sign here means the signs in the parentheses are going to be the same. Okay, now if I want to know what those signs are, I got to look at the B term. The B term is plus, so these are going to be plus. Then I need two numbers that multiply to 50 and add to 15. So the plus sign actually at the C term actually tells me two things. It tells me whether the signs will be the same or different, and it tells me whether my two numbers that should add or subtract to the B term, 15. So what multiplies to 50? 1 times 50, 2 times 25, 5 times 10. Okay, well, I'm looking for 15. I'm looking for them to add to 15, so the 5 and the 10 work. The order doesn't matter. I could have put the 10 first or the 5 because the signs are the same, so the order doesn't matter. Let's come across to this one. Again, my C term is plus. That tells me that the signs inside the parentheses will both be the same. The minus sign tells me they're both minus. So now I need two numbers that multiply to 35 and add to 12. So 7 times 5 would work. I could also put 5 and 7. Okay? Alright, down to this one. Things are a little different now. Now I have a minus for my C term. What that tells me is that one of my parentheses would be plus and one of my parentheses would be minus, because that's the only way I could get, when I double distribute, that's the only way I could get a minus at the end. So I got to think of all the numbers. This tells me signs are different. Okay, so now I have to think of numbers that multiply to 30. So 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Now I need two numbers that also subtract to 7. So that subtraction sign tells me signs are different, but it also tells me that I'm subtracting to get the 7. Well, no. 10 and 3 works. But you notice I'm not rushing to put the 10 and the 3 in there. I have to now, with the signs being different, I have to think about where the numbers are going to go. Okay? In order to double distribute to get a plus 7 here, I need the 10, the larger number, to go to the plus, and the 3 to go to the minus. Okay, so I always think where the bigger number is going to go. Okay, 21 is a minus. That tells me the signs are different. And the order of the signs doesn't matter. It's the order of the numbers that's going to matter. And I need numbers that multiply to 21 and subtract to 4. So 1 times 21 or 3 times 7. Well, 3 and 7 subtract to 4. Now this time the b term is minus. So the 7, the larger number 7, will go to the minus. And the 3 will go to the plus. Okay? A hack. If there's a number that's large in your C term, and you're just not sure if you could list all the factors in your head, one hack, let's say we're talking about the number 72. Okay, you know, maybe you've tried all the factors you could think of for 72 and you can't think of any more, but you haven't hit on the combination that works. So one hack would be 72 divided by x. And then look at your table. Okay? If you look at your table, you would look at all the rows that are whole numbers. So 1 times 72 is 72, 2 times 36, 3 times 24, 4 times 18. Anything with a decimal in it, skip, because we're always looking for whole numbers. 6 times 12, 7 we skip. 8 times 9. Now, 8 times 9 and 9 times 8 are the same thing. So I don't have to keep scrolling through the list. I've gone as far as I need to, because any more factors I get are just going to be duplicates of the ones I've already seen, just reversed. Like I eventually see 12 times 6, but if I already have 6 and 12, I don't need it. So that's one hack you could use if you're having trouble thinking of the combination of numbers that are going to add or subtract and multiply to the number that you want. Another hack I want to show you is if you are not sure if you factored something correctly. Okay, you can type in your original function. Let's see, let's do one I've got here. Alright, so x squared plus 15, whoops, I didn't type the plus sign. X plus 50, and then when I factored it, I said it was going to be x plus 5 and x plus 10. Okay, now I recommend looking at the table because sometimes you won't see the graphs. As long as in your table your two y columns match, you did it correctly. If you mess up a sign or something and you look at your table, you will get different numbers for y's. Okay, that will be how you know that you did it wrong. Okay, you'll get different numbers. You go back and look at how you factored things. In your homework, in 1 through 10, you're just being asked to factor out the greatest common factor from each problem. Okay, that's what we did on that other worksheet that I sent home. Some of them won't factor, all right? And if it doesn't factor, just write does not factor. Okay, I can see 2 right off the bat that I see don't factor. There may be more. Okay, so if I were doing number 8, say. In number 8, I'm looking at 20, 16, and 8. All of those divide, the largest number they all divide by would be 4. and x cubed, x squared, and x, they could all factor out an x. So 20 divided by 4 would be 5, and if I factor one of the x's out of x cubed, it would be x squared. 16 divided by 4 would be 4, factor out one of the x's. And 8 divided by 4 is 2, and the x got factored out. Okay? Now the next section of the homework is asking you to draw these algebra tiles. We are not doing that. I simply want you to factor like normal. Don't draw algebra tiles. Again, on the next section, do not draw these Punnett square type things. Just factor. Oh, too far. Now, a few of these have leading coefficients. And at least for the time being, this will change, but at least for the time being, the leading coefficient will factor out. For example, 4 is my leading coefficient, and it will factor out, leaving me w squared plus 3w minus 10. And then I can bring my 4 down and factor the trinomial that's left. Minus sign tells me signs are different. Plus 5 minus 2. 5 times 2 is 10. 5 minus 2 is 3. And the 5, the bigger number, goes to the b term sign, which is plus. I want to look at a problem like 39. 39 is not in standard form. You should have your squared term first. So I'm going to rearrange this equation to be in standard form. A negative m squared should be first, followed by minus 12m, followed by minus 32. Now, you do not want to try factoring with a negative leading coefficient. Remember, that's a negative imaginary 1. So we're going to factor out the negative sign. M squared plus 12m plus 32. Plus means, for plus 32 means signs are the same. Plus in front of the b term. 12 means they're both plus. And 8 and 4. 8 times 4 makes 32. 8 plus 4 makes 12. So look for problems like that. All right. Thanks, and have a great day.